this problem here. The figure above shows a regular hexagon with sides of length A and a square with sides of length A. If the area of the hexagon is 384 square root of 3 square inches, what is the area in square inches of the square? So a regular hexagon, this one here, can be divided into 6 equilateral triangles of side length A. It says here the sides of the length is A. Okay, by drawing the 6 segments from the center of the regular hexagon to each of its vertices. So let's draw that. So we have here 6 equilateral triangles with side length A. So if this is A, that means this is also A, as well as this, all of this. Since the area of the hexagon is given as 384 square root of 3 square inches, then the area of each of the equilateral triangle here will be 384 square root of square root of 3 divided by 6 square inches. So simplifying this, we will get 64 square root of 3, since 384 is divisible by 6. Therefore, the area of each equilateral triangle here is just equal to 64 square root of 3 square inches. You can write this as this one. Now, drawing any altitude of an equilateral triangle divides it into two 30, 60, 90 triangles. So if we draw an altitude here, okay, this will divide into 30, 60, 90 triangles for each of the equilateral triangle. So if we draw this one, okay, so this would be 60, 60, and 30, 30. And since the side length of each of the equilateral triangle is just A, so therefore the hypotenuse of each of the triangles here is A. And this altitude here, this one, is just opposite to the 60 degrees angle. So if we zoom it in, this is our triangle here, this one. Let's recall the 30, 60, 90 special triangle. So if this is 30 degrees and this is 60 degrees, okay, it's given that this is A, which is the hypotenuse. Okay, just do that later. So the side opposite to 30, let's say it's X, and then the side opposite to 60 degrees is X squared of 3, and then hypotenuse is just equal to 2x. Therefore, in here we're given the hypotenuse, which is A. So A is just equal to 2x. Therefore, x is just equal to A over 2. Therefore, this side here is equal to A over 2. And this side here is x squared of 3. So this is A over 2 squared of 3. Okay, and since the area of each of the equilateral triangle is equal to 64 squared of 3, we can equate 64 squared of 3 to the formula in finding the area of a triangle. So to find the area of the triangle, that is just equal to 1/2 base times height. So our area, we just plug in all the given values. The area for each equilateral triangle is 64 squared of 3 equals 1/2, and the base here is A. And height, we got the height, square root of 3 over 2 A. So that is square root of 3 over 2 A. Then we simplify that. This is just 64 square root of 3 equals square root of 3 over 4a squared. Therefore, a squared here is just equal to 4 over square root of 3 times 64 square root of 3. Square root of 3 here cancels out, so we are left with 4 times 64, which is just equal to 256. And then we get the square root of both sides, therefore a is equal to 16. Okay, so the value of a here is equal to 16. Since we have a square here, we need to find the area of the square, and the area of the square is just equal to a squared, so we can just write 16 squared, or this is just equal to 256, or we can just answer this directly. The a squared equals 256. We don't have to get the square root of that, so the answer here is 256 for the area of the square. Let's solve another problem here. In the xy plane, the point 36 lies on the graph of the function f of x equals 3x squared minus bx plus 12. What is the value of b? So it is given here that the function f of x passes through the point 36, this one, and then so that means that if x is equal to 3, then y, or f of x, is equal to 6. Now we can just plug in the values of x and y to the function, to the equation here, to find the value of b. So that would be f of x equals 3x squared minus bx plus 12. We plug in the value of f of x, which is 6, and then the value of we've plugged in the value of y, or the f of x, which is 6, and then also the value of x, which is equal to 3, minus b times 3 plus 12. So that would be 6 equals 3 times 9 minus 3b plus 12. Then we simplify that and group like terms. This is 27 plus 12 minus 3b. So that is 6 equals 39 minus 3b. Then we group 6 and 39, that is 6 minus 39 equals negative 3b. So this is just equal to negative 33 equals negative 3b. And to solve for b, we divide both sides by negative 3. This cancels out. So b is just equal to 11. Okay, the value of b here is 11.